We're here in a marsh in the Virginia countryside. Over there in the grasses are some egrets. In this pond are tadpoles, fish, snails. This wetland is teeming with life. But you might not realize this is also a way of filtering out waste from water. That's right. The waste from upstream, the farms, developments, sewers, whatever, it all ends up down here. And what this wetland does is make sure that the water leaving here is cleaner than the water that came in. Nature is able to do this because one organism's waste is another. This log, for example, will slowly and safely rot and return to the soil. How does this work for water filtration? Well, let's see what happens when you design a marsh to purify water.
Orlando, Florida, home to Disney and over a residence, growing faster than anyone had imagined. New sewage treatment plants became loaded to the hilt. Algae blooms were warnings of dangerously high nitrogen and phosphorus levels. The problem was traced to those treatment plants, and the city was told to dumping its treated waste into the rivers. They decided to construct their own wetland to clean the water. The city found a farm on the banks of the St. Johns River, bought it, and returned it to its natural state, a swamp. This is the deep marsh area. Troublesome nitrogen and phosphorus are removed and stored by cattails and bulrushes. And there are hundreds of other species of plants here to help clean up the water. Diversity rules. Not only does the Orlando system work beyond expectations, it actually attracts more wildlife than surrounding natural wetlands. Over 145 species of birds live here. 10 are on endangered lists, including the Everglade kite.
The Everglade snail is now inhabiting and nesting on the site. The Everglade snail kite feeds primarily on apple snails. Apple snails are a very important part of the ecosystem here at the wetlands. They're only found in very clean waters. As a matter of fact, regulators often use them as an indicator organism to see if water quality is meeting state standards.
Incredibly, the wetland will attract another species too, humans. The city has plans to open the area to camping. Campers who will quickly forget they're in a sewage treatment marsh. Constructed wetlands like this work, but you need lots of land. But what if you can't find it or afford it? Burlington, Vermont, a city of 130,000, is the state's largest, an economic and cultural hub on the shores of Lake Champlain. Because so much of their identity is tied to the lake, extra taken not to pollute it. The city's brand new $18 million sewage treatment plant is located right on the shore. Some cities are beginning to think it would be better to move the treatment closer to the source of the sewage. But most people don't want a sewage plant in their neighborhood, unless perhaps it looked like this.
The beauty of it is that it doesn't stink and it's pretty.
This is what the next generation of treatment plants might look like. Sewage you could be proud of. More a botanical garden than a sewage plant. It's the living machine, the brainchild of John Todd.
The reason why it's called a living machine is that the vast majority of the parts that make up the machine are alive. And you've got everything from microscopic bacteria that you can't see, all the way to bald cypress, fish, and clams. So the full panoply of life is represented in a living machine. This is the first tank. The raw, screened, untreated sewage enters here. You notice how the plants are wrapped to be off the surface to help protect their roots from the high-strength waste at the early phase.
80,000 gallons per day of raw sewage are drawn from the South Burlington treatment intake. That's the waste from about 400 homes, a large neighborhood. The waste goes through a series of concrete tanks, 14 feet deep, covered with plants and filled with bacteria, snails, clams, and fish that actually live off the waste.
Here you have a community made up of cyanobacteria, blue-green algae, and algae. And down here where the light is less intense, texture of algae with the microbial communities. And then grazing on these, as you can see, are the snail communities. They're vastly complex, and they really do act to trap particles that are in water and degrade them.
According to the EPA, the living machine can clean wastewater just as well as conventional systems. But a key to this design is that it makes sewage treatment pleasant, accessible, and more likely to be found anywhere and everywhere. Neighborhoods, apartment complexes, and commercial and industrial areas, even downtown.
So the last phase, the last cell in the roughly 2-day cycle, which you can see that it's very clean. The journey is done. It's good quality water. I can see one thing in here. That's a tiny little swimming around in the water. See it? Apart from that, there's nothing. Beautifully treated water. And this is where the water leaves the building and starts its journey to Lake Champlain. We're going to see an absolute transformation in how we see waste treated in the next 20 years. We're talking an industrial ecology here that starts with waste, but where it ends, nobody knows yet. All we know is a lot of good things can happen.
And a lot of things are happening all across the country. At Howard High School in Chattanooga, Tennessee, a group of students is working to clean up Chattanooga Creek. The creek, a toxic legacy of the city's industrial past, flows right through their neighborhood. It's an EPA Superfund site. And the students are figuring out how to clean up the toxic sludge using bacteria and common plants.
This is duckweed.
The plants actually survive off of the polluted water. Some people call it the living machine, but we call it the Howard School wetland system.
And the water flows from the wetland to the pond. And the ponds is where the fish and the animals live.
And we have a good quality of water if they actually survive. So that way we will know that our system is actually working because the invertebrates that we put in are actually living. So that would be an indicator that it's a good water quality.
These are coffees.
What we want this system to do is give us the knowledge so that we can build a bigger model like this one, especially for the Chattanooga Creek, to help that get cleaned up.
Wetlands by themselves may not be able to clean up all the water at the scale of large cities. For that, several technologies will have to work in concert with this one. But it can be done.